Okay, good day everyone. So this is me again, Engineer John Ray Montarola. Okay, this is for the subject elementary electrical engineering. Okay, so this is our second video discussion. So our topic for this meeting, for this video is circuit configuration. But before we start, let's discuss what is a circuit. No? In order for electricity to flow, we need power source and a closed circuit. Okay, so a power source is the one that provides electrical energy, or the one that pushes the electrons to flow in order to energize the load. Closed circuit. A closed circuit, if ever there's a closed circuit and you have the power source, okay, so therefore the load might be energized. Okay, so circuit configuration has two circuits, has two types, has two circuit can be connected in one of the two ways. Okay, the first one is series circuit, second one is a parallel circuit, or a combination of the two. Might be a series parallel circuit or a parallel series circuit. But before we are going to proceed that one, so let's discuss first what is series circuit and what is a parallel circuit. So a series circuit, okay, all the components are connected end to end. Okay, so end to end. As you can see, example, this is a resistor. Okay, so has two terminals, This one, that red circle, So this is one end and then another end, So, and then another resistor, another resistor. So as you can see, the one end of the resistor is connected to the beginning end, beginning or the terminal. If we are going to consider this terminal 2, terminal 1, terminal 2, this terminal 1 and terminal 2 for the second resistor. So the terminal 2 of resistor 1 is connected to terminal 1 of the resistor 2, connected. Okay, so this blue line is connector, it might be a type of wire, okay. And another end is connected to the other end of the resistor, another resistor, so on and so forth. As you can see, there is only one or only single path for current to flow. So, if makita dire, once the current is entering to the circuit, so there is only one path for the current. So, when it flow to resistor 1, then it flows also to resistor 2, resistor 3, resistor 4. Okay? So, only one path for the current to flow. What about the parallel? In parallel, both ends of the components are connected together. Okay? So, terminal 1, terminal 2 of resistor 1. Okay? So, and terminal 1 and terminal 2 of resistor 2 are connected. Terminal 1, all the terminal 1 are connected together. And all this terminal 2 of all components are connected together. Okay, so these are components of the circuit, So what are the types of components? It might be a resistor, a battery, capacitors, diodes, inductors, and so on and so forth. For the components, type of components of the circuit. Okay, so series circuit. In series circuit, there is only one pathway for charge flow. So we have discussed lately. So in series circuit, okay, so repeat lang. No, there's only one path for the electron to flow. So in other words, all the components are in series with each other. Because there is only one path, each charge will go through each resistor. So for example, okay, so there is 120 volts. Okay, so for example, if the voltage drop of load 2 is 80, so 80, so 120 minus 80, so that is the answer here, no? This is the total, no? 120 is the total. So what is lacking is pila naman lang. So 40, no? So we have 40 volts here. So if there is 12, we have 4 here. We have 3 here. So 4 plus 3 is 7. So 12 minus 7 is this one. The answer is this one. Okay? So the answer is 5. 5 volts. So there is only one path. Okay? So when the current flow here, the same also current that flows here, no? And the total current. Same also here, no? Total current flows here, and then here, and then here, and go back to the negative terminal of the source. Okay, so now, predict, no? Test and explain. How will the brightness of the bulbs change as we add more in series? Okay, assume that the bulbs are typical, no, of the same characteristics, the same rating, the same wattage, and so on and so forth. So how will the brightness of the bulbs change as we add more in series? And the second one is, what does this imply about the current in the circuit? So if you add more and more and more bulbs connected in series of the same, no, wattage, the same characteristics, the brightness will equally distributed, no? Equally distributed, no? Since they consume the same, no, the same amount of current. Okay, what differs, or what will happen if you add more and more and more bulbs is the brightness will decrease, no? Will decrease, gradually decrease, no? If you add one, if you this one, for example, okay, so the brightness, for example, is 100%, no? It brights, no, 100%, and you add another one, so might be it will become 98%, and if you add another to 96%, and so on and so forth. Okay, so what does this imply about the current in the circuit? Equally distributed, or is equally distributed ang iyahang voltage. At the same time, the current is the same all throughout the circuit, no? The same all throughout the circuit. Okay, so for example, if 1 ampere flows to bulb number 1, and then that is also the amount of current that flows to second bulb, no? So on and so forth, no? Okay, so same amount of current, equally distributed, that means the same current flows to each of the bulb. Okay, so Kirchhoff's law, no? Kirchhoff's law. So Kirchhoff's law has two types, no? KCL and KVL, no? In KCL, Kirchhoff voltage law, if KVL, I mean the sum of all the voltage, okay, voltage drops in a series circuit equals to the total applied voltage. In KCL, Kirchhoff's current law, okay, or the total current in a parallel circuit equals the sum of the individual branch currents. Okay? So, balik ko na ko, in KVL, the sum of the voltage drops in a series circuit equals to the total applied voltage. As you can see here, anyway, if the total voltage applied to the circuit is 120, and then you have a voltage drop to the second bulb of 80 volts, and then what is the amount here, no? So that is why 120 minus 80 is 40, no? 40. So 40 volts ang naa dali napita, no? The drop. So 40 plus 120 is equal to 40 plus 80 is equal to 120. KCL, no? Voltage na pod, current na pod. So the word current, KCL. Okay? So it is applicable to the parallel circuits nga naman. Since, no? Ano naman dili man siya ma-apply sa series. So here, as I've said, all throughout the circuit, okay, has only one path for current. So that means all throughout has the same amount of current. So you cannot apply KCL here. But what differs here is might be dako ni siya voltage drop, gamay. So nagdiferensya lang sila sa voltage drop. Okay, so natay voltage drop dire, nasa voltage drop dire, nasa voltage drop dire, and so on and so forth. Okay? So, series circuit that contains only one path for current is this one, no? Kita na to sa illustration. If the path is open, everywhere in the circuit, the current stops flowing to all components. As I've said, the current cannot jump. No? It will never jump. No? So that there is, even the circuit is open, the current will jump. No, doesn't mean it is not possible. So for example lang, you remove the second bulb, so the current will flow from positive conventional flow from here to the first bulb, then goes here, and then until here. So the current will be stagnant here, no? Stagnant. The current will never jump, no? Will never jump to the other side. Okay? So it means there is no current that returns, no, to the negative terminal of the source. Okay, so series circuits. Characteristic of a series circuit is this one. The current flowing through every series component, no? Series component is capacitor, resistor, is equal. The second one is the total resistance, or RT, is equal to the sum of all the resistances, no? Of all of the resistances. Like for example, R1 plus R2 plus R3, no? Is equal to the R total. Okay? So totalo lang nimo, i-add lang nimo tanan nimo mga resistances. The sum of all of the voltage drops BR1, BR2 plus BR3 is equal to the total applied voltage, as I've said ganina. So this is called Kirchhoff's voltage law, no? Kirchhoff's voltage law, or KVL. So VT is equal to BR1 plus BR2 plus BR3. Okay, calculating resistance in series circuits. So how to solve? Okay, add up the values of each individual in the series, no? Add up. So 5 plus 5 plus 3 is 13, no? RT is equal to R1 plus R2 plus R3. Okay? So 5 plus 5 plus 10 is 20 ohms. So add lang na nimo, add basta series. Okay. Next is we have 5, 5, 3. Add up, no? Add up the values in series circuit. Okay, R1 plus R2 plus R3. So that is, wala ko na usap diri. So 10 plus 20 plus 10, no? So, example lang, 10 is yan, 20 na 10. Okay, so, tara. Wala isa na i-erog. No? So, supposedly this is 10, this is 20. So we have a total of 40 ohms. Now, let's proceed to example, no? For the series circuit shown below, okay, in this figure, use the laws of circuit theory to calculate the following: total resistance, the current flowing through each component, IT, RR1, IR2, and IR3. Okay, so the voltage across each component, VT, VR1, VR2, VR3. Okay, so muna yung mga circuit or the voltage across each component. Okay, so use the results to verify Kirchhoff's voltage law. Okay, now this is the schematic diagram. Okay, this is the schematic diagram. The total voltage source is 12 volts. We have total current. We have VR1, the voltage across R1. We have R1, which is 220 ohms. And then, we have R2, which is 470 ohms. Okay, and we have IR2. Another resistance is 1.2 kilo ohms. Okay, so 1.2 kilo ohms, the voltage drop assigned to this is VR3. Okay, and this time you can solve for the total resistance since all of the resistances are given, no? So to solve this one, okay, total resistance is add lang na natutanan, no? 220 plus 470 plus 1.2. So the total is, okay, so supposedly 1890 na siya, no? Since kani 220 plus 470 is okay, so 690 plus 200, so 890, no? So 1890 supposedly kilo ohms, no? Ohms. But here, i-round off niya. Okay, so iyang ibutang nila 1.9. So in our exams, no, do not copy this one, do not follow this one, but write the exact, no, the exact value, no, so that error will be avoided, no. So like example here, current through each component, okay, V over RT, so also, so here nigamit siya 1.89, no. So balik na po noon, layo na nung kayo ka, no. So IT, so is equal to VT over RT. So mao man atong kuan ang I, so V over R. So from Ohm's law, this is the original formula for Ohm's law. So IT is equal to 12 volts. So 12 volts atong source divided by 1.89. So we have a total of 6.3 milliamp, or that is 6.3 M capital A. Series circuit is a series, since this is a series circuit, IT is equal to IR1 plus RR2 plus IR3 plus, IT is equal to, since connected in series, IT is equal to IR1 is equal to IR2 is equal to IR3, which is equal to 6.3 milliamp or mA. Okay? So take note this one. If connected in series, then IT is equal to IR1 is equal to IR2 is equal to IR3. Okay? Voltage across each component. Okay, so here voltage drop. No, we are going to solve for the voltage drop across each component. No, VR1, IR1, Ohm's law. No, derivation. 6.349 milliamp times 220 is equal to 1.397 volts.
VR2 is equal to IR2 plus R2, which is equal to, which is coming from the Ohm's law, no? So substitute, no? 6.349 plus 470 is equal to 2.984 volts. So to solve for VR3, so substitute 6.349 times 1.2 kilo ohms, which is equal to 7.619. Okay. Now let's verify. No, let's verify if those computed values obeys KVL. No, obey KCL, KVL. I mean. Okay. So remember, our total voltage is 12 volts. So dapat, no, according to the law, the sum of all voltage drops is equal to the total source, no? Total voltage source. Okay? So expected R1 is equal to R1, R2, R3. Okay? So we have VR1, we already solved the VR1, we have VR2 and VR3. Okay, so 12 volts is equal to 1.397 plus 2.987 plus 7.619. Okay? So, total 12 volts is equal to 12 volts. So, meaning, it obeys, no? KVL. Okay, so that's all for this meeting. I hope you learned something. Thank you for watching. God bless, my dear students.